This is just a walkthrough on how to solve the heat capacity problems. This sheet is posted without the video as well. So let's take the question where we want to calculate the energy needed to change 100 grams of ice from -10 to 20. Um, and so if we look on the phase change diagram, -10 is going to be somewhere around here. And we have three things we need to do. We need to raise the temperature of the ice to 0. Then we need to melt it, and then we're going to raise the temperature of the water, because the ice is all melted now, it's water, all the way up to 20. So we have three different equations we're going to have to work through. We're going to have to work through number one, being this part here. Well, that's awfully thick, where we're raising the temperature of the ice. Number two, where we melt the ice. And number three, where we raise the temperature of the water. Sorry, it's so big there. All right, so number one, raising the temperature of the ice from -10 to 0, because 0 is the melting point of water. So as we do that, it's going to be the mc delta T equation, because we're changing the temperature. And so we have 100 grams. Now we're going to use the heat capacity of ice, not the heat capacity of water, because ice is what we're changing the temperature of. And then where the change in temperature is 10 degrees, that we can see right here. So 100 times 2.06 grams joules per gram degree C times 10 degrees C gives me 2.06 kilojoules, or 2060 joules. We need to be able to switch back and forth between kilojoules and joules, and it's just dividing by 1,000. And that's written up here as well. All right, so we've just raised the temperature of the ice. We had to put in that much energy. Now we want to melt the ice, and we're going to want to use the molar heat of fusion, not the molar heat of vaporization, because fusion is the state where the liquid is fused to a solid. So we're going to use that number. And that's just going to be M or NLF, where N is the number of moles. So we take the number of moles here, which is 100 divided by 18, because it's 18 grams per mole for water. And then we're going to multiply it by the heat of fusion, which is 6.02 kilojoules per mole. And we get 33.4 kilojoules. Finally, now that all the ice is melted and we have water, we want to raise the temperature of the water to 20 degrees. That's what it said in the problem to do. If we go up here, we're changing it to 20 degrees. So it's mc delta T again, mass of the water, the heat capacity of water, because now it's water, and 20 degrees C, and we get 8.36 kilojoules. If we add up these three numbers, 2.06 plus 33.4 plus 8.36, we get the total heat required, and that total comes out to be 43.8 kilojoules with the right significant figures. There you go. So let me know if you have questions. I hope this helps you solve the problems. Here for answers anytime you need.